Okay, so we are going to skip number 32 and number 36 for these examples. So when you're looking to simplify a rational expression, you have to simplify the top first and then the bottom second. And you're simplifying them separately. So I'm looking to simplify this and this by using factoring. So they're both binomials, which means they're either going to be DOPS or GCF. And what I notice about the first two is that z squared is a perfect square and so is 36. So I'm going to use DOPS on this one. And with DOPS, our parentheses are the square roots of our terms. Just one has a plus with it and one has a minus with it. So I know the square root of z squared is z, and the square root of 36 is 6. So I'll have a z plus 6 and a z minus 6 as my factored form. For the next one, 4z minus 24, 4 is a perfect square, but 24 is not. So because it's a binomial, that means it must be a GCF. So I'm going to math arrow to the right 9 and find the GCD between these two things. And what I end up finding is that it's 4. And I'm not going to write 4z because that 24 doesn't have a z. So I can just divide a 4 out from each of these. And when I divide that 4 out, I end up with z minus 6. So now if I'm writing my original fraction in factored form, the top z squared minus 36 is z, let me put it down here, is z plus 6, z minus 6, and the bottom 4z minus 24 is 4, and then z minus 6. And then what I see here is that the minus 6's match perfectly, so I can cancel them out and write the problem without them. So my final answer is z plus 6 over 4. Looking at the next one, I'm looking to factor q plus 1, and I'm looking to factor q squared plus 4q plus 3. Because q plus 1 is a binomial, I know it's either going to be DOPS or GCF, and it can't be DOPS because it's not subtraction. So I'm going to go try to do a GCF for this, and I'm also going to notice that there's not a GCF because they both don't have a q, and then the only number they'd have in common is 1, and 1 is in a GCF. So I can't factor this one. It's actually just going to have to stay as is. This one over here is going to be an a equals 1 problem because it's a trinomial and the first term is 1. So I'm going to go to my y equals screen and I'm going to do a c, which is 3 divided by x, and I'm going to look side by side for two numbers that add to 4. And those numbers are positive 3 and positive 1. So if I'm going back to the original problem, I couldn't do anything to the top, but I could factor the bottom to q plus 3 and q plus 1. And what I notice is that the plus 1's match perfectly, so I can cancel them out. Because the q plus 3 is in the bottom, it has to stay there. And so I don't have anything in the top, so I'm just going to put a placeholder 1 there so that it holds the spot of the numerator. For this next problem, I'm looking to factor a minus 2 and a squared minus 4a plus 4. A minus 2 is a binomial, so it's either going to be DOPS or GCF. It can't be DOPS because 2 is not a perfect square. So I'm thinking it would be GCF, but when I do a math arrow to the right 9 of 1 and 2, the only GCF I have is 1, and that's not a GCF, and they both don't have variables, so this one can't factor. This one's going to be a equals 1 because the leading coefficient is a 1x squared and it's a trinomial. So I'm going to do a y equals 4 divided by x in my calculator, and I'm going to look for two numbers side by side that add to negative 4. And once I find those numbers, I put them directly into my blanks. So that's negative 2 and negative 2. So if I write my original problem, in factored form, I couldn't factor the top, but the bottom is a minus 2, a minus 2. We can only cancel out one a minus 2 with one a minus 2. So I'm left with an a minus 2 in the bottom. And because I'm left with nothing in the top, I have to put a placeholder of 1 to hold its place. For this last problem, I need to work on factoring x squared minus 13x plus 40 and 2x minus 10. X squared minus 13x plus 40 is a trinomial, and since the first term is x squared, this is an a equals 1 problem. I'm going to go to my y equals screen and I'm going to do a 40 divided by x. And what I'm looking for is two numbers that add to negative 13. And those go directly into the parentheses. 2x minus 10 is a binomial, so it's either GCF or DOPS, and because 2 isn't a perfect square, it must be GCF. So if I do a math arrow to the right 9, I find that the GCF between 2 and 10 is 2. And I'm not going to put an x on that because the 10 doesn't have an x. So I'm just going to divide a 2 out from these things. So now I have my factored form. My top is factored as x minus 8, x minus 5, and my bottom is factored as 2, x minus 5. Because the x minus 5s match perfectly, they can cancel out, and I'm left with x minus 8 on the top and 2 on the bottom as my final answer.